In this video, we will determine the enthalpy of vaporization of water at various temperatures, ranging from 5 to 95 degrees Celsius. We need to look up the molar isobaric heat capacity of liquid water and water vapor from a reliable resource. And also, we need to know the enthalpy of vaporization of water at a given temperature, any temperature. But here, I'm giving you this enthalpy of vaporization of water, 40.65 kilojoule per mole at 100 degrees Celsius under the normal pressure, which is 1 atm pressure. So now, here's the question. Does the enthalpy of vaporization of water depend on temperature? The answer is yes and no. So I want to say yes because the molar isobaric heat capacity of liquid water differs from the molar isobaric heat capacity of water vapor. And the temperature dependence of the enthalpy of vaporization is the difference in the molar isobaric heat capacity, which is non-zero. However, if you really integrate this molar isobaric heat capacity from, for example, 100 degrees to 50 degrees, you will see that integral is fairly small, much smaller than this 40.65 kilojoule per mole. So in that sense, you may say no, approximately, the enthalpy of vaporization of water does not depend on temperature, approximately. So now I'm going to show you some numerical calculations to demonstrate my answer of yes and no is reasonably correct, depending on how much approximation you would like to make. Because we need to do the calculations at 10 different temperatures, I'm going to use Excel. I looked up the CPM of liquid water and water vapor. There's two numbers. Just remember, the CPM of liquid water and water vapor also depend on temperature, but the temperature dependence is negligible between 5 degrees Celsius to 100 degrees Celsius. So I'm going to just use the data at 25 degrees Celsius. And then we're talking about vaporization, so the change of CPM is product minus the reactant. Therefore, we have this cell B3, water vapor, minus cell B2, the CPM of liquid water. And then I converted this number to kilojoule per mole K because we want to use a consistent unit. And now this is given to us. The enthalpy of vaporization is 40.65 kilojoule per mole at 100 degrees Celsius. So what about the enthalpy of vaporization at 95 degrees Celsius? Well, over here, 40.65, this is our baseline. And we need to integrate this delta CPM over here. This is delta CPM from 100 degrees Celsius to 95 degrees Celsius. Fortunately, this delta CPM is treated as a constant here. So when you do this integral, it's simply the change of CPM over here, a very small number, multiplied by the temperature change from 100 to 95. So this is the equation. 40.65, this part is the enthalpy of vaporization at 100 degrees Celsius. Now we're going to look at the difference between 95 and 100. So I'm using 95 minus 100 and then multiplied by delta CPM. Fortunately, again, this delta CPM is roughly a constant between 5 and 100 degrees Celsius. And then I'm going to just double click this filled tiny square here, and we filled out all the cells. So you can see at 5 degrees Celsius, the enthalpy of vaporization is 44.6 kilojoule per mole. 100 degrees, well, 40.65 kilojoule per mole. If you look at the difference, well, yeah, indeed, the enthalpy of vaporization does depend on temperature. However, within this very large temperature range, nearly 100 degrees Celsius temperature range, the enthalpy of vaporization changes by roughly only 4 kilojoule per mole. And even better, if you look at a smaller temperature range, let's say between 55 and 100, you can see, well, you have 40.65 all the way to 42.53. I want to say, well, the percent of the change is no more than 5%, so it's pretty good. But experimentally, if you measure the enthalpy of vaporization within such temperature range, you're going to see the final result is not going to be 40.65. It's not going to be 42.53. If you do everything accurately, you're going to get a number between 40.65 and 42.53 if your data were collected between 55 degrees Celsius and 100 degrees Celsius. All right, so that's why even if you do everything correctly, your final result may not be 40.65. It may not be 42.53. It's going to be a number in between if the data were collected between 55 degrees Celsius and 100 degrees Celsius.